In just a single night of observations, the Vera C. Rubin Observatory uncovered more than 2,000 asteroids that had never been identified before. That number is remarkable, not because those objects pose an immediate danger, but because it reveals how much of our own cosmic neighborhood has remained unnoticed. Among the discoveries were several near-Earth asteroids, and while none of them threaten our planet, their existence raises an important question. If thousands of previously unknown objects could be found so quickly, how much has escaped our attention until now? Our solar system is far from empty. It is filled with countless asteroids, icy worlds, comets, fragments left over from planetary formation, and perhaps even visitors that originated around distant stars. Most of these objects will never come close to Earth, yet every one of them tells a story about how our solar system formed billions of years ago. Some could also become important for future planetary defense efforts. What makes Rubin extraordinary is its ability to repeatedly scan enormous portions of the sky, allowing astronomers to detect even the faintest objects as they slowly shift against the background of distant stars. Instead of revealing a quiet universe, its first observations exposed just how much activity has always been taking place beyond our notice. The observatory's earliest discoveries were not distant galaxies or exotic black holes. They were objects much closer to home, silently traveling through the darkness of our own solar system. During only a few hours of testing, Rubin identified over 2,000 previously unknown asteroids. That achievement is extraordinary because these objects were never hidden behind some mysterious barrier. They were always reflecting sunlight and following their natural paths through space. Humanity simply lacked the right instrument to detect them efficiently. This changes the way we think about astronomical discovery. Traditional telescopes often focus on small sections of the sky, studying one target at a time with incredible detail. While this approach has produced countless breakthroughs, it leaves little opportunity to monitor everything that is constantly changing. The universe never pauses. Asteroids continue their orbits, comets brighten and fade, distant stars explode, and rare visitors from outside our solar system may appear without warning before disappearing forever. Missing the right moment can mean missing the event entirely. Rubin was designed to solve exactly that problem. Rather than staring at a single object for hours, it repeatedly sweeps across huge areas of the night sky. Each new image is compared with previous observations. If a tiny point of light changes position, astronomers immediately know they are looking at something much closer than the distant stars. That moving dot could be an asteroid, a comet, or another object worthy of closer investigation. Even an ordinary-looking rock can provide valuable clues about the earliest history of our solar system. This is why discovering thousands of new asteroids in such a short time is more than an impressive statistic. It demonstrates that our inventory of nearby space is still far from complete. The solar system is not a collection of isolated planets traveling through empty space. It is a constantly changing environment filled with countless small bodies moving in every direction. Many are tiny, many are harmless, and many have remained invisible simply because no previous survey could search the sky this quickly or this often. Rubin is much more than another powerful telescope. It functions as a continuous monitoring system for the sky, capable of detecting changes before they go unnoticed. Whether the goal is protecting Earth from potentially hazardous objects or expanding our understanding of planetary history, its ability to observe movement on an enormous scale makes it unlike any observatory before it. Perhaps the most fascinating part is that these discoveries were not made because the asteroids suddenly appeared. They were always there. The difference is that humanity finally built an instrument with the speed, sensitivity, and field of view needed to find them. And this is only the beginning. Over the next decade, Rubin will continue scanning the southern sky night after night, building the most complete record of moving objects ever assembled. The observatory's greatest strength comes from its ability to observe an immense area of the sky in every exposure. Many famous telescopes are designed to magnify tiny regions with extraordinary precision. The Hubble Space Telescope transformed our understanding of distant galaxies through detailed observations, while the James Webb Space Telescope peers through cosmic dust to reveal some of the earliest structures in the universe. Rubin follows a different philosophy. Instead of concentrating on one small target, it surveys vast regions of space over and over again. At the heart of the observatory is the largest digital camera ever constructed for astronomy. With a staggering 3.2 billion pixel sensor, each image captures an enormous section of the sky while preserving enough detail to reveal extremely faint moving objects. That combination of wide coverage and high resolution is exactly what makes Rubin so effective at discovering new asteroids. Finding these objects is not simply about taking sharp photographs. The real challenge is returning to the same region repeatedly and identifying what has changed. A distant star remains fixed, but an asteroid shifts slightly from one image to the next. Those tiny movements become unmistakable signatures, allowing astronomers to identify new objects with remarkable efficiency. As Rubin continues its survey, the night sky transforms from a collection of still photographs into a living movie. Every observation adds another frame, revealing countless objects traveling through the solar system. The thousands of asteroids already discovered are only the opening scenes of a much larger story. Scientists expect the observatory to identify millions of previously unknown objects over the coming years, including main belt asteroids, near-Earth objects, Trojan asteroids, distant icy worlds, and many faint bodies that older surveys could not reliably detect. Rubin may also become one of humanity's best tools for finding interstellar visitors. Objects similar to Oumuamua and Comet 2I, Borisov likely pass through our solar system more often than once believed. Until now, many may have escaped unnoticed because they were detected too late or not at all. By scanning the sky continuously, Rubin greatly increases the chances of spotting these rare travelers while they are still close enough for detailed study. For the first time, astronomers are beginning to build a true inventory of everything moving through our corner of the cosmos. Not only the planets and famous comets, but also the countless fragments, icy bodies, and temporary visitors that quietly cross the sky before disappearing forever. The more Rubin discovers, the more complete our picture of the solar system becomes, and the more we realize how active the universe has been all along.